Today I'm going to teach you how bonding takes place in magnesium chloride and also to find out what type of bond is taking place, whether it's a covalent bond or an ionic bond. Now, if you look at the electronegativity table and see the electronegativity difference, you'll see if the electronegativity difference is 0.0 to 0.2, the type of bond formed will be a non-polar covalent bond. If the electronegativity difference is from 0.3 to 1.4, then the type of bond formed will be polar covalent bond. And if the electronegativity difference is more than 1.5, then the type of bond formed will be an ionic bond. Now, if we look at the periodic table and look into the electronegativity of magnesium, the electronegativity of magnesium is 1.31. And if we look at the electronegativity of chlorine, it is 3.16. So the electronegative difference between magnesium and chlorine is about 1.85. So if you look at the table, if its electronegativity difference is more than 1.5, then it will be an ionic bond. So magnesium chloride will go through ionic bonding, or ionic bond is present in it. Another way to identify is when one is a metal, the another one is a non-metal. When the elements are metal and non-metal, then a it will be an ionic bond. And if both are non-metals, then it will be a covalent bond. Now, next thing that we have to understand in order to show the bonding that takes place in magnesium chloride is the electronic configuration of magnesium and chlorine. Now, again, if we look at the periodic table and see the atomic number of magnesium, it is found in group 2 and the atomic number is 12, and chlorine is found in group 17 and atomic number is 17. Now, writing down the electronic configuration. Magnesium, we just now saw, has an atomic number of 12, so its electronic configuration will be 2, 8, and 2, whereas chlorine has an atomic number of 17, so its electronic configuration will be 2, 8, and 7. Now, if we look at the electronic configuration, we'll see magnesium has 2 electrons in its outermost shell or orbit, whereas chlorine has 7 electrons in its outermost shell or orbit. So, what we see and observe is that chlorine requires 1 electron to become stable, whereas magnesium can give 2 electrons to become or to achieve inert gas configuration of 2 and 8. But we see chlorine requires only 1. So the better choice will be if one magnesium gives 1 electron to each or to 2 chlorine, then the bond formation of magnesium chloride can take place easily. So let us draw the bond formation. Magnesium we can show magnesium having 2 electrons with a dot and then draw 2 chlorine and each chlorine will have 7 electrons each. We can show the electrons by making cross 1, 2, 3, 4, 5, 6 and 7. Another chlorine 1, 2, 3, 4, 5, 6 7. Now, the transfer of electron from one magnesium to the other chlorine and then to another chlorine. So now we observing that magnesium is giving one electron to the first chlorine and another electron to the next chlorine. Now finally we can write this as Mg, we can put it in a square bracket, and 2 plus, that means it has a charge of 2 plus because it is giving 2 electrons, and now it has 2 and 8 electrons, plus, and then another bracket, and we can show chlorine. How many chlorines are there? 2 chlorines are there, so we can make a 2 over there, and plus charge because each chlorine is taking 1 electron, and now its electronic configuration becomes 288. Finally, we can write down MgCl2. So this will be the final compound. Now, what did we see? The positive and the negative ions in magnesium chloride are held together by electrostatic attraction between opposite charge, and they form an ionic bond. I hope you understood this.